All right, folks. Today I want to do a sample of a homework problem that mimics sort of the essence of the problem from written homework number one, question three, and the last two parts, part E and F. Have you dividing one fraction by another fraction? So this is just my remark. Dividing fractions, huh? How do we do that, right? So some of you might be saying, well, oh, easy, flip and multiply, right? That's one of the rules that we will get to halfway through the semester as far as how to operate with fractions. But remember, we're putting ourselves in our future students' position where they've just learned fractions yesterday, right, in their fourth grade or fifth grade class. And so all they're operating on is the definition of a fraction. So that's all we're going to be operating on. However, if they're learning division in school, then they also already learned multiplication in school. And so we're going to be reviewing our definition of multiplication from 107A and sort of converting these into a sort of fill-in-the-blank multiplication problem. And then we'll sort of reason that out on a number line. Okay, so almost everything we do with fractions in this course at this point will be on the number line because that's how we use the definition. That's how we show that we're breaking our whole up into a certain number of pieces. Yeah, so if you want to double check your answer by flipping and multiplying, on scratch work and don't include that in the written homework, that's okay. If you want to use a calculator and verify your answer that way, by all means do that sort of outside the scope of the course. But in the course, we're always putting ourselves in the shoes of our students already. So the first question, number E or letter E, says 1/2 divided by 1/8. I'll leave that for you folks to do in the homework, but let me do something similar. So let's say I want to do 1/3 divided by 1/9. All right, a little bit similar. And so that's what we're told to do. So again, we don't want to rely on a calculator or any kind of shortcut tricks that we haven't justified as valid yet in this course. So I want to think about this. So we're asked what this equals to. And so it equals something, right? It equals something. And so if I put that something there, you can use an algebraic variable like an x if you want to. Well, question mark is fine. That's just our unknown. And so remember, missing factor it was called. I used to represent it MF. Missing factor was essentially our definition of division. So let's refresh our memory with whole numbers, just how exactly where the pieces went when we converted it to a multiplication problem. So let's say I have 8 divided by 2. Right, so let's just think of some whole numbers. So if I tell you guys 8 divided by 2, in 107 you consider different ways of thinking about division. So you could say I've got 8 items and I want to form 2 equal groups, right? So 2 could represent the number of groups. How many items live in each group? And you might say 4, right? If I've got 2 groups of 4. Another way you could say that, so that would be if you had 1, 2, 3, 4, 5, 6, 7, 8 items, and you're thinking I want to form 2 equal groups. 1, 2 equal groups. How many items live in each group? And then I've got 1, 2, 3, 4 items per group. Okay. There was another alternative way of sort of asking that question, but it leads to the same answer. You could say I've got 8 items and I want to form groups of 2, right? So instead of splitting it into the number of groups, you could be dictating the size of the groups. You might say, okay, so here's a group of 2, 1, 2, 3, 4. How many groups did I form? 4, right? So we had different models that we could interpret division. But then finally, when we got to our definition, the missing factor, if we didn't know the answer, we'd say 8 divided by 2 equals something. And the way I used to always do it to maintain sort of the position here is 2 times something equals 8. All right? Which in this interpretation, that means 2 groups of some certain size equals 8. Also in 107B, 107A, you discussed or verified, proved that multiplication of 2 whole numbers is what we called commutative. So you could switch the order and interpret the question differently. All right. But then we would say, well, what's our question mark going to be? We already know the answer is 4. 2 groups of 4 will equal 8. There we go. Okay. So that's the idea here is I want to take this division problem and I want to apply missing factor, our good old 107A definition of division. So that's still going to hold up. And that definition is still going to hold up. We're just doing it in terms or context of fractions right here. So I always drop down vertical right here. So this says 1/9 times something is equal to 1/3. All right. At our question now, let me get rid of this but we want to know what is something, or what is something equal to. That's our ultimate question. So that's what I mean by a fill-in-the-blank multiplication problem. Okay, so now again, let's think back to definition of multiplication. M times n means m groups, right, or m sets of n items per group. Right, and there's different interpretations of that, sets, however, whatever you want to think. However, so n sort of refers to the size of the set, the size of what you're adding up or counting up, and then m was telling us how many times to add that up, or how many of those groups, or how many of those sets we were combining. Okay, so multiplication, we always interpret how many of what. All right, so here I've got 1/9 times question mark. That means 1/9. So the way I could interpret this right now is 1/9 of some unknown quantity is 1/3. All right. I'm going to take advantage of my commutative property of multiplication. So commutative property of, I can say, use x for multiplication. Right, my symbol. So commutative property of multiplication is going to justify why I want to switch this around. Or, I'm sorry, that's going to justify why I am allowed to switch that around. Okay, so I'm allowed to do that. And now this is the sort of mystery, or this is the puzzle I want to solve right now. And why do I want to do that? Because if I try to figure out that I want 1/9 of some unknown quantity, right, then I've sort of got to split this unknown quantity into 9 equal pieces and then collect one of them, right? And that's going to be a little bit hard to do because it's an unknown. So instead what I'm doing here is I want to take some number of 1/9, and I want that to be the same as 1/3. Okay, so now this is the how many, and so that's going to be a little bit easier to deal with. All right, so once we sort of unwind and restate what we're looking for, now let's jump into the problem using the definition of a fraction. Okay, so step 1 of the definition of a fraction is establish some kind of whole. All right, so I'm just going to draw a number line, come way out, try to avoid. I've got a lamp in my room that reflects right there, so let me kind of leave that there. And what do I want to do is, at some point I want to see what a 9th is. So let me try to get 9 equal pieces here. All right, I'm going to use the short end of the eraser, go a little bit, about a centimeter past the short end. 1, 2, 3, 4, 5 pieces I've got so far. 6, 7, 8, 9. So establish my whole right there. All right, so as soon as I get my number line set up and I mark where 0, 1 is, I've established the whole. All right, if I marked where 5 and 6 was, you can establish the whole that way because there would be the difference of one whole number in there, but 0, 1 makes the most sense. Okay, and just to double check, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 equal segments. So if I want to go ahead and label all of those, I can. Let me label 1/9 right there. Okay, so now let's interpret the question. I want some number of these 1/9 segments. So I'm going to count up segments or collect segments of length 1/9 and see how many of them it takes to get to 1/3. Okay, so I've already established, I've split my whole into 9 equal pieces. So the first piece is 1/9. I'm going to locate where 1/3 is. All right, so remember there was a previous example that we looked at in class together where we had a whole and it was split into 7 equal pieces, right? So we had a whole split into 7 equal pieces, and we wanted to locate where 1/3 was. And so to do that, because sevenths and thirds, right? That 7 and that 3, we weren't really able to split these segments up into 3 equal pieces. So what did we do? We discussed maybe splitting those into 2 equal pieces, splitting those into 3 smaller equal pieces, and then it ended up working. So sometimes you'll have to do that. If you've got your whole split up into some number of segments, and you want to locate where some other fraction with a different denominator based on different number of segments is located, sometimes you might have to start splitting up pieces. However, in this case, we luck out because my whole is split into 9 equal pieces. And so if I want to represent that same whole split into 3 equal pieces, I know 3 groups of 3 forms 9, right? In other words, I could do, let's say, check, check, check. There's a group of 3. I can do X, X, X. There's a group of 3. And I can do happy face, happy face, happy face. So I've got 1, 2, 3 groups of 3 built right in. So that's nice. Let me indicate that, though. And let me use the secondary color, and maybe I'll make my marks a little bit larger. And so let me indicate that right here. So I want to 3 of these. 1, 2, 3 of them. And 1, 2, 3. Let me sort of overlap that a little bit with the blue. Overlap that a little bit with the blue. And find 1/3. Okay? So this is key right here. The method that I wanted to do this. So I rewrote my problem. I located the size of my chunks here, and I located my goal. And now the question becomes, how many of these 1/9 do I need to equal 1/3? In other words, how many of them should I move over or add up until I get to exactly here? And so let's just count. If I do 1, 2, 3 of those groups, that looks to work, right? In other words, 3 groups or 3 chunks of the size 1/9 lands me at the same spot as 1/3. If I collect 3 of these 1/9 segments, that's the same as collecting 1 of the 3 larger segments in my whole. All right, and so I've solved for question mark. What is question mark equal to? Question mark is equal to 3. What is question mark equal to in the context of our original problem? The answer, right? The quotient or the answer to that division problem. So at this point, I know 1/3 divided by 1/9 is equal to 3. All right, and if you're the type that couldn't help but divide, flip and multiply, or use a calculator, or double check, or sort of pre-check that answer before we did it the long way, then that's believable. That makes sense, okay? But that right there, that's the process that we want to carry that out. So if I was showing this on work, everything I've shown here would be part of my submission. That would all be part of my work. The work of the number line, the rearrangements here, the justification, right, of previously learned topics from 107 is going to be part of it right there. That extra number line I did with the 7ths, that was a previous example just to emphasize how this could be a little bit more challenging. Alrighty, but that's the idea right there. So now, if the 3 and the 9 had less in common, could this process become more challenging? Sure, and it will, right? But this is a nice introductory strategy right there.